Hey everyone. So in the last couple of videos, we've developed the Keynesian Cross model. We've shown how it moves, how planned investment can change based on different government policies. So in this video, we're going to focus on deriving the investment savings curve, the IS curve, from the Keynesian Cross. So in the Keynesian Cross so far, we've primarily assumed that investment was exogenous. But to get to the IS curve, we're going to have to allow investment to change a little bit. And so the IS curve is just a graph of all of the combinations of the interest rate R and income Y that bring the goods market to equilibrium, that bring planned expenditure to actual expenditure. And so the IS curve is just all equilibria from the Keynesian Cross model. And our equation for the IS curve is really straightforward. It's exactly the same as that total income equation that we had in chapter 3. We have income is a function of consumption, which is a function of disposable income, investment, which is now a function of the interest rate. It is now endogenous to our model, and government spending, which is a policy variable. And so there's two ways to derive the IS curve. The first one, we're going to use the Keynesian Cross model. So we'll start with just a basic Keynesian Cross. Where we have PE is equal to Y, and PE is equal to C plus I R plus G. Okay? And so in this one, we're going to allow the interest rate to change. So we're going to say that we start here at interest rate R1. Now think back to chapter 3, we said that investment was negatively related to the interest rate. When the interest rate was really, really high, investment was going to be low. When interest rates fell, when interest rates go down, investment's going to go up. And so we can see how investment is going to change planned expenditure based on changes in the interest rate. So let's say the interest rate falls. It goes from an interest rate R1 to an interest rate R2. With a lower interest rate, we're now going to have more investment spending. Our investment spending is going to increase, which is going to increase our total planned expenditure. We're now going to have PE is equal to C plus I of R2 plus G. And so at R1, we were at this point right here, Y1, right? And when interest rates fell, it increased total spending and it shifted us out to Y2, okay? And so we can take that and graph that to a relationship between the interest rate R and total income Y. And so we were initially at this point Y1, and we'll say that we started at interest rate R1. We were initially at this point right here. And we can say that interest rates fell from R1 to R2. When interest rates fell to R2, it increased total spending, or planned spending, and it shifted that PE curve upward and brought us to this new income level Y2. And so with interest rate R2, our new equilibrium level of income was Y2 right here. And connecting those, we can see this inverse relationship between the interest rate R and total income Y. That is our IS curve. That is the negative relationship between the interest rate and investment. And so just to keep it straight, we still have Y1 and Y2, just like we had before. And so when interest rates fell, a decline in the interest rate led to an increase in investment. An increase in investment increased planned expenditure. So PE went up, And when planned expenditure goes up, because our equilibrium condition is PE is equal to Y, that meant that Y had to increase as well. And so we see this negative relationship where a fall in R, a fall in the interest rate leads to an increase in total income. So on the other side of that, we can actually derive the IS curve from the loanable funds market that we had in chapter 3. We can go a slightly different direction and get exactly the same result. And so I'm going to clear everything we've got so far. And let's take just the basic loanable funds market that we had in chapter 3. So we had savings and investment on the x-axis and the interest rate on the y-axis. We had a downward sloping investment curve. And let's say that we initially start right here, the savings level S1. Now we know that in this model, you save a constant amount of your income, right? Your marginal propensity to consume, let's say it's 0.8. So if you spend 80% of your income, you save 20%. So hypothetically, let's say that income falls. If income falls, that means savings has to fall. You're saving the same portion of your income, but you have less income. And that shifts total savings to the left. And so lower income means lower savings, and that shifts us to S2. And so at S1, we had equilibrium interest rate R1. And when income fell, it decreased total savings and increased the interest rate. And so we can graph that back to the IS curve. We can show the relationship between a change in income that caused the change in savings and the change in the interest rate. And so if at S1, we started at point Y1, say right here. So we started at R1 and Y1. Let's say that income were to fall to Y2. When income fell to Y2, it decreased our total savings. And when it decreased our total savings, that increased the interest rate to R2. And so we can connect these and see exactly the same. See exactly the same IS curve that we had previously. So this decline in income from Y1 to Y2 decreased savings. And when we decrease savings, we increase the interest rate. And so we still have this exact same negative relationship between interest rates and income. And so we can take this and see how different policies are going to influence these things. And so just to keep everything straight, the IS curve is always going to be negatively sloped. A lot of times people keep the mnemonic device IC slopes to keep in mind that the IS curve will always slope downward. So as interest rates fall, that increases firms' desire to invest. Basically, it's less costly to invest, so firms are going to invest more. When firms invest more, that increases planned expenditure, PE. And the only way that we can restore equilibrium in the goods market, according to the Keynesian Cross model, is for when PE to go up, for Y to also increase. And so when investment goes up, because of a lower interest rate, that means our total income has to go up. And so we can take that and look at different fiscal policy responses through the IS curve. This is exactly the same thing that we were doing with the Keynesian Cross model, but we can now incorporate the interest rate to it. We don't have to assume that investment is exogenous. We can see how that's going to change based on changes in government spending or taxation. And so we can start with just the basic Keynesian Cross model, just like we've had everywhere else. So if we have y on the x-axis and PE on the y-axis, PE is still equal to C plus I plus G. If we start at government spending G1 and we increase total government spending, that's going to shift this entire curve upwards, right? Just like we saw in the last video. So we now have PE, hang on just a second. PE is equal to C plus I plus G2. Okay? We can bring that over here to the IS curve. Now, importantly, the Keynesian cross model assumes that interest rates don't move. So this is I of R1 and this is I of R1. It's going to be the same amount of investment. So we are right here at R1. And so if we were initially at Y1 in this model, then down here our IS curve is at that same Y1. And so we have IS curve IS1. And when we increase government spending, that's going to shift this entire IS curve to the right to Y2 because we're assuming that the interest rate stays constant. So we're going to shift the IS curve to Y2. So we now have IS2 with a higher level of income at each interest rate. And so at any given value of R, higher G leads to higher planned expenditure, which leads to higher income. And so the IS curve is going to shift to the right. And the distance that the IS curve is going to shift is our government spending multiplier. So the distance the IS curve shifts is that delta y is equal to 1 over 1 minus MPC times delta G. And so the IS curve is going to shift by that total government spending multiplier.